Hello friends, welcome to online lecture series. This is the 16th lecture of unit number 1, that is biomechanics. Okay, so in our previous lecture we discussed about separation of variable in polar coordinates. Okay, so today we start numericals which are based on Schrodinger equation in polar coordinates. Okay, so first one is question is normalized wave function. Wave function is given psi is equal to n e to the power minus r upon a0. Okay, wave function is given here, variable is r, so it is related with polar coordinates. Okay, so first one is, what is the normalization condition? Normalization condition, it means suppose any one function is normalized, that at that time square of that function integration on it is equal to 1. Okay, if two different functions are given at that time, integration of psi 1 into psi 2 is equal to 1. Okay, it means product of two different wave function integration on it is equal to 1. If only one wave function is given at that time, square of that wave function integration on it is equal to 1. Okay, so in this case first theta is a volume element. For polar coordinates the variables are, first one is r, second one is theta, and last one is phi. Okay, so these three are variables for polar coordinates. So volume element for polar coordinates, theta is equal to r square sin theta dr d theta and d phi. Okay, so here the variables are r, theta and phi. Okay, so first one is a boundary condition also given. It means the value of r is lies between 0 to phi, the value of theta is lies between 0 to pi, and the value of phi is between 0 to 2 pi. Okay, so first in this case we need a triple integration calculation for, because the variables are three, r, theta and phi. Okay, so we apply triple integration on function, that is psi. Okay, so triple integration of function psi, it means here the value of r, it means r is lies between 0 to infinite, it means the value of limit is 0 to infinite for r variable and 0 to pi for theta variable, 0 to pi for theta variable, and limit 0 to 2 pi for phi variable. Okay, so put the value of psi is equal to n e to the power minus r upon a0. So I put the value of psi square. Okay, so square, and the volume element d tau is equal to r square sin theta dr d theta and d phi. Okay, is equal to 1. Here in this case first n is a constant, so it goes outside of the integration. Now n square, it means n square goes outside of the integration, and now I apply integration of separate variable. It means here 0 to infinite for r variable, it means 0 to infinite, here this term contain r variable and this term contain r variable. So r square into e to the power, now e to the power minus r upon a0 square, it means e to the power 2r upon a0, and variable is r, it means dr. Okay, so limit 0 to infinite for r variable, it means here I separate all the three integration term. It means 0 to infinite for r variable, this term r square and e to the power minus 2 upon a0 into dr. Okay, and this term contains theta variable, it means 0 to pi sin theta into d theta, and 0 to 2 pi phi is equal to d phi is equal to 1. Okay, so first what is the basic integration formula of this type equation? Okay, so this is the basic integration formula of x to the power n into e to the power minus ax into dx is equal to, first one is n factorial. N means here x to the power n, here power is given r to the power 2, so the value of n is equal to 2. Okay, so the value of n is equal to 2, and what is the value of a is the coefficient of x, a is the coefficient of x. Here coefficient of r, it means minus 2 upon a0. So the value of a is equal to minus 2 upon a0 in this case. Okay, so in this equation variable is x, but in our equation this variable is r. Okay, so the value of n is equal to 2 and the value of a means coefficient of x. Here the value of a is minus 2 upon a0. Okay, so put the value of n factorial. N factorial means here the value of n is equal to 2. So 2 factorial divided by a to the power n plus 1. It means a is equal to minus 2 upon a0 to the power 2 plus 1 is equal to 3. Here the value of n is equal to 2. So 2 plus 1 is equal to 3. Okay, and integration of sin theta. Integration of sin theta is equal to minus cos theta and limit is 0 to pi. Now integration of 1 with respect to phi. Integration of 1 with respect to variable phi is equal to phi. Limit 0 to 2 pi is equal to, here n square is in multiplication with in left side. If it goes right hand side, then it will become a denominator term. Okay, so the value of this equation, it is first term. So for solve this equation, we must have knowledge about this equation. It means x to the power n e to the power minus x is dx is equal to n factorial. N means power, variable power. Here variable r, so power is variable is 2. So 2 factorial divided by a to the power n plus 1. N plus 1 means 2 plus 1 is equal to 3 and the value of a is coefficient of x. So here coefficient of r is 2 upon a0. So 2 upon a0 to the power 2 plus 1 is equal to 3. Okay, so first one is, what is the value of 2 factorial? 2 factorial means 2 into 1 is equal to 2 and cube of 2, it means 2 into 2 into 2 is equal to 8 and a0 cube. Here a0 goes upper side. Okay, so 2 into a0 cube divided by 2 to the power 3 is equal to 8. Okay, so 2 into a0 cube divided by 8 into, now this minus sign remains as it is, and first put the value of upper limit in place of variable. Variable is theta. Okay, so put the value of pi. First cos pi minus lower limit, it means cos 0. Cos pi minus cos 0. Here same as first put the value of upper limit in place of variable. So 2 pi minus 0. Okay, so first minus cos pi minus cos 0, 2 pi minus 0 is equal to 1 upon n square. Okay, so here in this case, so what is the value of cos pi? Cos pi is equal to minus 1. Minus cos 0 is equal to 1. Okay, so this term will become minus 1. Minus 1 is equal to minus 2. Minus 2 into minus 1, it means minus minus plus. It means minus 2 into minus 1 is equal to plus 2. Okay, and the value of 2 pi minus 0 is equal to 2 pi is equal to 1 upon n square. Okay, so in this case we cancel out 2 to the 4, 8. Okay, so this term all cancel out. So the remaining term is a0 cube into pi is equal to 1 upon n square. The remaining term is a0 cube into pi upon 1 upon n square. So the value of n square is equal to 1 upon pi a0 cube. Okay, so now in next step I take square root on both sides. Therefore n is equal to under root 1 upon pi a0 cube. So the value of n is equal to under root of 1 is equal to 1. It means 1 upon pi a0 cube. Now I put the value of n in function. Function is equal to n e to the power minus r upon a0. So the value of n is equal to 1 upon under root pi a0 cube. Okay, so I put the value of n here. So finally we get function sin is equal to 1 upon pi a0 cube into e to the power minus r upon a0. Okay, so this is the normalized wave function for hydrogen atom. This is the normalized wave function for hydrogen atom in polar coordinates. Okay, so first question is given normalized wave function function also given psi is equal to n e to the power minus r upon a0. Okay, so first one is what is the normalization condition? Integration sin square d term is equal to 1. D term is a volume element. Volume element means for one dimensional box our particle is moving only x direction, so volume element will become dx. In 3 dimension the volume element will become dx into dy into dz. Okay, but in polar coordinates there are 3 variables r, theta and phi. Okay, so the volume element will become r square sin theta dr d theta and d phi. Okay, and what is the limit of r? R is lying between 0 to infinite. For theta 0 to pi and for phi 0 to 2 pi. Okay, so put the value of all the limits in integration term. Okay, so we need a triple integration for solve this question. So first triple integration of function square, it means this n into e to the power minus r upon 0 square into volume element, this is the r square sin theta dr d theta and d phi. Okay, is equal to 1. So first one n square, n is a constant so it goes outside of the integration, so n square here e to the power minus 2r upon a0, it means square of e to the power minus r upon a0 is e to the power 2r upon a0 into r square sin theta dr d theta d phi is equal to 1. Okay, so first separate all the variable. This term it means r with respect to r, with respect to theta and with respect to phi. Okay, so first one is 0 to infinite for r term, this and this one. Okay, 0 to pi for theta term, so this is only theta term, sin theta into d theta, and 0 to pi for a phi term, it means 1 into d phi. Okay, so this is the basic calculation of this type integration. N factorial upon n plus n, so put the value here, n is equal to 2, so 2 factorial divided by a is a coefficient of x, here the value of a is equal to 2 upon a0, 2 upon a0 to the power n plus 1, here value of n is equal to 2, so 2 plus 1 is equal to 3. Okay, so solve all these general basic mathematical calculation, final we get the value of psi is equal to 1 upon pi a0 cube into e to the power minus r upon a0. So this is the normalized wave function for hydrogen atom. In next question I will use this wave function. In next question is calculate 1s energy for 1s orbital. Okay, so this wave function is also used in our next question. Okay, so this is the normalized wave function of hydrogen atom. Okay, so next question is calculate the energy of 1s orbital. Psi 1s is given. Psi 1s is equal to 1 upon under root pi a0 cube into e to the power minus a upon r upon a0. Okay, so this is the last equation of in our previous question. Okay, so this is the normalized wave function for hydrogen atom. Okay, so first write the Hamiltonian operator. Hamiltonian operator indicates the total energy of the system. Okay, so it is the sum of two types of energy, kinetic energy plus potential energy, but kinetic energy in terms of polar coordinates will become minus a square upon 8 pi square m into 1 upon r square into 1 upon del r into bracket r square into del by del r. Okay, so this term indicates the value of kinetic energy and this is the potential energy. Okay, but in our 3-dimensional box where the value of potential energy is 0, it means in 3-dimensional Cartesian box, it means but here in this case the value of potential energy is not 0. The value of potential energy capital V is equal to minus E square upon R in hydrogen atom or Schrodinger equation in polar coordinates. Okay, so first apply the eigenvalue equation H psi is equal to E psi. Okay, so first operate this Hamiltonian operator on function psi 1s. Okay, H psi is equal to E psi. Here indicates the value of eigenvalue, but in this equation it is the energy. Okay, so we calculate this E. Okay, so first apply Hamiltonian operator on function. At that time h into psi, left hand side is equal to h into psi. If I multiply psi in this bracket, so psi is multiplied at 2 times, first at 2 position. First one is this position, kinetic energy, and second one is potential energy term. Okay, psi is multiplied with 2 different terms. Here in this case I put the value of psi. Psi is equal to 1 upon under root pi a0 cube into e to the power minus r upon a0, because this term contain differentiation equation, but in this case I will not put a value of psi. Okay, so first minus a square upon 8 pi square m 1 upon r square del by del r square del by del r, and the value of psi is equal to 1 upon under root pi a0 cube into e to the power minus r upon a0 minus e square upon r. Psi 1 is remain as it is. Okay, so first multiply Hamiltonian operator with function psi. Okay, so now in next step this term remain as it is, minus a square upon 8 pi square m 1 upon r square del by del r, but here in this case del by del r it means differentiation of this term, differentiation of this term. Now in this term variable is r. Okay, so 1 upon under root pi a cube is a constant, so it goes outside the differentiation. Okay, so r square into 1 upon under root pi a0 cube. Now d by dr of, it means differentiation of e to the power minus r upon a0, it means here in this case differentiation of e to the power is remain as it is, e to the power minus r upon a0, but in this case it means differentiation of power also, at that time r is variable, so remaining term is minus 1 upon a0, so it will goes multiplication with this term. Okay, and minus this indicates this is the value of potential energy term remain as it is. Okay, so first differentiation of this term. Now second differentiation is also d by dr. Okay, so first minus a square upon 8 pi square and 1 upon pi r square. Now d by dr of this term, it means d by dr of second differentiation of this whole term. Okay, so now in first term all terms are in multiplication. Now in first term all terms are in multiplication. Okay, so first minus a upon a0 is a constant, minus a upon a0, and 1 upon under root pi a0 is constant, differentiation with respect to variable r, so only r contained variable term is r square and e to the power minus r upon a0, so these two terms are constant, so it will goes outside of the differentiation. At that time minus will become plus. Okay, so a square upon 8 pi square m 1 upon r square into 1 upon a0 and 1 upon pi under root pi a cube, both are constant, so it will goes outside of the differentiation. Okay, so differentiation of r square into e to the power minus r upon a0 and minus this is the potential energy term, so it will remain as it is. Okay, so now differentiation of two different function, it means the multiplication rule of differentiation. At that time first term remain as it is, and differentiation of second term, at that time first term remain as it is, it means e to the power minus r upon a0 remain as it is, and a differentiation of second term, that means a differentiation of r square is equal to differentiation of r square 2r into 2 minus 1 is equal to only 2r. Okay, so 2r minus r square remain as it is in differentiation. Now in first term all terms are in multiplication. Now in first term all terms are in multiplication. Okay, so first minus a upon a0 is a constant, minus a upon a0 and 1 upon under root pi a0 is constant, differentiation with respect to variable r, so only r contained variable term is r square and e to the power minus r upon a0, so these two terms are constant, so it will goes outside of the differentiation. At that time minus will become plus. Okay, so a square upon 8 pi square m 1 upon r square into 1 upon a0 and 1 upon pi under root pi a cube, both are constant, so it will goes outside of the differentiation. Okay, so differentiation of r square into e to the power minus r upon a0 and minus this is the potential energy term, so it will remain as it is. Okay, so now differentiation of two different function, it means the multiplication rule of differentiation. At that time first term remain as it is, and differentiation of second term, at that time first term remain as it is. It means e to the power minus r upon a0 remain as it is, and a differentiation of second term, that means a differentiation of r square is equal to differentiation of r square 2r into 2 minus 1 is equal to only 2r. Okay, so 2r minus r square remain as it is, and differentiation of this term e to the power minus r upon a0 remain as it is, and coefficient is minus 1 upon a0 is multiplication with it. Okay, so it will become here minus. Okay, so this term remain as it is, a square upon 8 pi square m 1 upon r square 1 upon a0 under root pi a0 cube remain as it is, and differentiation of this term and this term also remain as it is. Okay, so now I common out two terms in this bracket. Okay, so first one is this minus e upon minus r upon a0 common out, as well as I common out r square. At that time here not r square, so I multiply this equation with r and also divide r. Okay, so 2r square upon r, so I common out r square into e to the power minus r upon a0 in this term. Okay, so r square and minus 2r upon a0, at that time the remaining term is 2 upon r minus here this term is called common out, so it will become minus a upon a0, and this term remain as it is. Okay, so this is the potential energy term. Now r square both are cancel out. Here r square and this r square both are cancel out, and remaining term is a square upon 8 pi square m 1 upon a0 under root pi a0 cube into e to the power minus r upon a0 2 upon r minus 1 upon a0 minus e square upon r psi 1s. Okay, so from Bohr atomic radius we know that the value of a0 is equal to a square upon 4 pi square m into e square. Okay, so this equation we studies in our 11th standard. Okay, so a0 is equal to a square upon 4 pi square m into e square. Now I want the value of this term is square upon 8 pi square m. Okay, so here I divide this equation with 2. I divide this equation with 2 both sides, so 4 into 2 it will become 8 pi square m. Here is e square is denominator, so it will goes numerator. Okay, so the value of a square upon 8 pi square m, it means a square upon 8 pi square m, a square upon 8 pi square m is equal to a0 into e to the power 2 divided by 2. Okay, so the value of a square upon 8 pi square m is equal to a0 e to the power 2 divided by 2. Now I put the value of a square upon 8 pi square m, therefore the value become a0 e to the power 2 divided by 2 and 1 upon a0 under root pi a0 cube e to the power minus r upon a0 and 2 upon r minus 1 upon a0. Now I put the value of psi 1s. Okay, psi 1s is equal to 1 upon under root pi a0 cube into e to the power of minus r upon a0. So and now I put the value of psi 1s in potential energy term. Okay, so now in this case which terms this equation contain two terms here minus. Okay, so first one is this term indicates the value of kinetic energy term, and this is the potential energy term. Okay, so this equation contain two terms, first and second. Now which things are common in both step? First one is e to the power minus r upon a0, e to the power minus r upon a0. Here a square, a0 cancel, e square is also common out, e square, and e square 1 upon under root pi a0 also common out. Okay, so remaining term is e square into e to the power minus r upon a0 and under root pi a0 cube is common out into both term. Here 2 is 1/2, it means 2 is in division. So if I multiply 1/2 with this equation, at that time these two and these two are cancel out. So remaining term is only 1 upon r. And 2 is also multiplied with this term, it means 1 upon minus 1 upon 2a0. Okay, so 1/2 multiply with this term, at that time 2 cancel, 1 upon r minus 1 upon 2r0, and here remaining term is minus 1 upon r. Okay, so we common out three different terms. First one is e square, second one is under root pi a0 cube, and last one is e to the power minus r upon a0 in these two term. Okay, so remaining term is a0 cancel, 1/2 is multiplied with this equation, this at that time 2 cancel, 1 upon r minus 1 upon 2 into a0, and remaining term in this case only 1 upon r. Okay, so this 1 upon r and this 1 upon r both are cancel out, plus minus. Okay, so remaining term here, the value of 1 upon under root pi a0 cube into e to the power minus r upon a0 is equal to sine 1 upon under root pi a0 cube into e to the power minus r upon a0 is equal to sine. So e square, here remaining term is minus 1 upon 2a0. So it will multiply with this equation, it means minus e square upon 2a0, this 1 by r and 1 by r cancel out. Okay, so remaining term is minus e square upon 2a0, and this term will become sine. Okay, so sine 1s. So this is the right hand side. Okay, so left hand side is sine. First we apply Hamiltonian operator on function, and last term we get same function. Okay, so the value of e is equal to, so the value of e here h sine is equal to e sine. So first we apply function with Hamiltonian operator, and finally we get same function. Okay, so the value of e is equal to eigenvalue or energy is equal to minus e square upon 2a0. Okay, so the value of e is equal to minus e square upon 2a0. So if I put the value of e and a0 is 1 unit, at that time if a is equal to 1 and a0 is also is equal to 1, at that time 1 square divided by 2 into 1, it means minus 1/2 is equal to minus 0.5 AU. Okay, so this is the second equation. Calculate energy of one s orbital function is given. So first one is write the Hamiltonian operator for polar coordinates. Hamiltonian operator is equal to kinetic energy plus potential energy. Okay, so first write the Hamiltonian operator, then operate this Hamiltonian operator with function. Okay, so first one is h psi, operate Hamiltonian operator with function. Okay, so this is the basic two terms. First one is kinetic energy and potential energy. Okay, so first del by del r of this term, it means differentiation of this term. At that time this 1 upon pi a0 is common out, constant, so it will goes outside the differentiation, and remaining term is del by del r of e to the power minus r upon a0. Okay, so del by del r of e to the power minus r upon a0 is equal to e to the power minus r upon a0 into minus 1 upon a0. Okay, and here in this case second time also differentiation d by dr, at that time minus 1 upon a0 and 1 upon under root pi a0 cube, both term are constant, so it will goes outside of the differentiation. This minus 1 and this minus 1 become plus, it means a square upon 8 pi square m 1 upon r square 1 upon under root pi a0 cube into 1 upon a0. Okay, so remaining term is del by del r square into e to the power minus r upon a0. into r e to the power minus r upon a0 into r square minus here this is the potential energy term. Okay, so differentiation of these two function, it means first one is e to the power minus r upon a0 remain as it is, and differentiation of r square, it means 2r plus r square remain as it is, differentiation of this function, it means e to the power minus r upon a0 into 1 minus 1 upon a0. Okay, so here this minus 1 upon a0 is multiplied with plus sign and it will become here minus sign. Okay, so this term contain 2r into e to the power minus r upon a0 minus r square e to the power r upon a0 divided by r0. So we common out in this term. First one is e to the power minus r upon a0 here and here also, and here r square is also common out. At that time r into r. Okay, so the 2r square divided by r, it means we common out r square. At that time remaining term is 2 upon r minus a upon 1 upon a0 minus this term remain as it is. Okay, so from atomic radius we note that the equation a0 is equal to a square upon 4 pi square m into a square. So the value of a square upon 8 pi square m is equal to a0 into a square divided by 2. Put the value of a square upon 8 pi square in this equation and finally we get a0 into e to the power 2 square 2 into 1 upon a0 under root pi a0 cube e to the power minus r upon a0 2 upon r minus 1 upon r a0. Now put the value of sin 1s. Sin 1s is equal to 1 upon under root pi a0 cube into e to the power minus r upon a0. So we common out three things. First one is e square, second one is 1 upon under root pi a0 cube, and last one is e to the power minus r upon a0 in these two term, and final value will become 1 upon r minus 2 upon 1 upon 2a0 minus 1 upon r. This 1 upon r cancel out both side. Okay, so e to the power minus r upon a0 divided by under root pi a0 cube is equal to function e to the power minus r upon a0 and under root pi a0 cube is equal to function of hydrogen atom. Okay, so here we get final value e square into here remaining term is minus 1 half minus 1 upon 2a0 into sin 1s. Okay, so these two terms are in multiplication, so minus e square upon 2a0 with sin 1s. Okay, so this is the eigenvalue. First one h psi is equal to h psi. First we operate Hamiltonian operator on function and last we get same function. And what is the value of a here? Here value of a is equal to minus e square upon 2a0. Okay, so the value of a is equal to minus e square upon 2a0. Okay, so what is the here is the energy for 1s orbital, is the energy for 1s orbital. If I put the value of a is equal to 1 unit and a0 is equal to 1 unit, at that time the value of a will become minus 1 half, it means minus 0.5 AU. Okay, so I completed all the theoretical and numerical parts of unit number 1, that is wave mechanics. So in next lecture I will start a new chapter. Okay, so thanks for watching this video.